Hello, my name is Joe Herrick. I'm gonna talk today about my course project for machine learning foundations for product managers. I'm gonna share my screen now. So, um, the main project topic is about building a model to predict the electrical energy output of a power plant, and we have data with different variables. The four variables that we have are temperature, ambient pressure, relative humidity, and exhaust vacuum. And this is the target variable, which is the net hourly electrical energy output. So I downloaded the Excel sheet and I'm going to use Excel to build my model. Um, and here we have the different steps in the modeling process that I need to go through. And I'm going to move now to my Excel sheet. So this is basically the main data set. Those are the four features that we have. Again, they are ambient temperature, ambient pressure, relative humidity, and exhaust vacuum. And we have here the predicted electricity output. So the type of machine learning approach that I'm gonna use is supervised learning because the main objective is to predict a target variable, and we also have the target data, which is shown here in column E. As for the output metric to evaluate the performance, I'm going to use the mean absolute error and the mean absolute percentage error. I'm not going to use the mean squared error because it's fine to being off by a lot one time in this exercise. So I'm going to go with the MAE and the MAPE here in this exercise. And then, the possible features that I might use in this model are shown here. So basically, these are the four variables that I might use, depending, on the analysis that I'm gonna do, and I'm gonna show you in a few seconds. And the algorithm that I'm gonna consider is basically a parametric algorithm. And to be more specific, I'm gonna use the linear regression task to identify the relationship between those features and the target variable, which is the net hourly electrical energy output. I'm gonna use specifically the multiple linear regression because in our case here we have more than one feature. We have actually four features. And for the validation strategy to compare different models, I'm gonna use the fixed validation. And for the validation approach to compare at least two different models. So what I did, I mainly tried to remove some features from the model to see the impact on the output metrics that I talked about here. And I used different combination of features and relied on the performance metrics to choose the final model. And in order to evaluate the performance of that final model, I calculated the output metrics, the MAE and the MAPE on my test set, and I compared them to the output metrics of the validation set. So what I did first, I split my data set, the main data set, which is shown here. I split them into three different data sets. One is training set. I took 60% of the data, 20% for the validation set, and also 20% for the test set. So I'm going to use first the validation data set, which is 20%. And I ran, the regression statistics, and you can see those two output metrics. We have 81% for the mean absolute percentage error, and we have 3.68 for the mean absolute error. Now, as I mentioned before, I'm gonna start, I looked at the coefficients, and what I did, I tried to remove one variable after another, mainly one feature after the other. So first I removed the AT, the ambient temperature, and I calculated those output metrics. And as you can see, we have a value of MAPE, which is over 100%. And this is because the errors are much greater than the actual values. So I'm gonna disregard this model, and I'm gonna move and remove the V, which is in this case the exhaust vacuum. So I kept only 3 features in this model, and I calculated the metrics. And as you can see, we have a relatively good MAPE with 85% and 3.86% for the mean absolute error. I moved to remove the ambient pressure, and we have a decreased MAPE compared to the previous model. So I'm gonna move. So far, the best model is this one, and I removed the relative humidity, and we have a very similar MAPE and MAE compared to the model without the exhaust vacuum, which is 85% as well. What I did next is I tried to remove a couple of features, and I removed the ambient temperature and the relative humidity here, and we have a MAPE again above 100%, which shows that the errors are much greater than the actual values. And the last model I tried to do is, I removed the exhaust vacuum and the relative humidity, and I got the best results. I got a 94% mean absolute percentage error and 4.24 on the mean absolute error. So I'm gonna rely on this model. I'm gonna choose this model, relying only on the ambient temperature and the ambient pressure to predict the target variable. And for the test set, this is again the 20% of the whole data set. I just ran the numbers for, including all the features just to see the numbers. You can see the MAPE is 81% and the mean absolute error 4.82. But when I use the model that I chose without the relative humidity and the exhaust vacuum, you can see that we have a great mean absolute percentage error with 96%, and we have a mean absolute error of 5.50, slightly higher than the previous one, but still a good model to rely on. Thank you very much.